Welcome to Math with Mr. P. Today we are doing 7th grade math. This is chapter 1, lesson 7. We are dealing with constant rate of change today. So, a rate of change is a rate that describes how one quantity changes in relation to another. In a linear relationship, the rate of change between any two quantities is the same. A linear relationship has a constant rate of change. So basically when we graph this, it should have the same rate of change between our like x coordinate to the next x coordinate kind of thing. And the same thing with the y coordinate. So a real world link here to kind of put it in perspective, a computer programmer charges customers per line of code written. Fill in the blanks with the amount of change between consecutive numbers. So for 50 lines of code, they charge $1,000. For 100, they charge $2,000. For 150, they charge $3,000. For 200, they charge $4,000. Notice that the rate changes at every single time. So 50 goes to 100. It's a difference of 50. We would write 50 here. From 100 to 150, it changes 50. From 150 to 200, it changes by 50. And down here, the cost will change 1,000 each time. So for every 50 lines of code this programmer does, he's going to charge 1,000. Now, this keeps this constant rate of change, meaning that he doesn't give a discount if you do more or something like that, like we've run into in the past. For every 50 lines of code, it will cost $1,000. So it doesn't matter if you do 50 or 200, 300, 1,000 lines of code. For every 50, it will cost you $1,000. So label the diagram below with the terms change in lines, change in dollars. So again, just like it says down here, we would have to divide these by 1 to see how much one line is. So if I divide by 50, it'll become 1. And if I divide 1,000 by 50, it will become 20. So basically, he's charging $20 per line of code. And this is how we find our unit rate. So we're going to use a table here. Here's another example. The table shows an amount, or the amount of money a booster club makes washing cars for a fundraiser. Use the information to find the constant rate of change in dollars per car. So we're going to find the constant rate of change in dollars per car. So for every 5 cars washed, it's $40. 10 cars, $80. 15 cars, $120. 20 cars, $160. So you see how the rate of change here continues to be 5, while over here we continue to go up by $40. Find the unit rate to determine the constant rate of change. So if we have $40 for 5 cars, we would divide both by 5 to get a unit rate, which means that 1 car equals $8. Now we're going to go ahead and do these got it problems. The table shows the number of miles a plane traveled while in flight. Use the information to find the appropriate constant rate of change in miles per minute. So the time goes from 30 to 60 to 90 to 120, which means they're each jumping up 30 minutes. Over here, our distance continues to go up. And the best way to figure this out and to solve this is to take the next step. So we're going to take 580 and subtract 290 from it to see if we have a constant rate of change here. 580 minus, and I believe it was 290. 0 minus 0 is 0. 8 minus 9 can't do. We'll borrow. This will be 18 minus 9, which will give me 9 still. And 4 minus 2 will be 2. So it looks like it's jumping up 290 each time. Now we can double check our work and see if 580 plus 290 will equal our next one, which will be 870. 9 plus 8 is 17. Carry the 1. 2 plus 5 is 7, plus 1 is 8, and it is 870. So we're seeing a pattern here that they're all going up by 290. I'm going to add 290 again to make sure that this is 1,126. This will be 16 carry, and this will be 1,160. I may have said the wrong number earlier. So 1,160, and it is 1,160. Therefore, it is going up by 290 each one. So we would take that 30 and that 290. So we double check to make sure that this is a constant rate of change, which it is. So for every 30 minutes, they travel 290 miles. Now I'd have to find a unit rate. So again, let's see if 290 can be divided by 30. And it cannot. But we're going to go average that. So we're going to change this. So 30 minutes will be on the bottom, 290 miles will be up top, because they're asking us to find the approximate constant rate of change in miles per minute. So 30 is a minute, distance of miles is 290. So we need to make this 1. So I have to divide both by 30. This will be 1, and as we did on our calculator, we divided 290 by 30. So 290 divided by 30 will give us 9.6 forever. So this is my unit rate, but my sentence answer should be that they're traveling 9.6, bar notation over the 6, miles per minute. And that would be my answer to that one. Table B, the table shows the number of students that buses can transport. Use the table to find the constant rate of change in students per school bus. So for 2 school buses, we have 144. 3 school buses, 216. 4 school buses, 288. 5 school buses, 360. So let's make sure that we have a constant rate. Here we do. They're each going up by 1. And over here, we're going to double check to see that everything is going up by the exact same amount. Now I'm going to use a calculator. 216 minus 144. Okay, they should be going up by 72 each time. So let's see. 144 plus 72 equals 216. If I add 72 again, it equals 288. And if I add 72 again, it's 360. So this is going up by 72 each time. Now, I'm going to take my original fraction or ratio, which was 2 school buses can carry 144 students. They want to know what is the constant rate of change in students per school bus. We're going to find out how many students can use one school bus. We're going to divide this by 2 because we want the school buses to be 1. And 144 divided by 2 equals 72. So one school bus can house or hold 72 students. Now we're using a graph to represent the distance traveled while driving on a highway. Find the constant rate of change. So here we've got 1 hour going 60 miles, 2 hours going 120, 3 hours going 180. So we're going to find the constant rate of change. To find the constant rate of change, pick any 2 points on the line, such as 0, 0, and 160. So we had 0, 0, which meant they didn't do anything, and 1 to 60 is, 1 hour, 60 minutes, or 60 miles that they travel. So they're traveling 60 miles per hour, which is what they said here. So I know this looks a little bit confusing, so let's go ahead and use this example of using 160 and 120. We would go with the bigger point and do 120 minus 60. So same way here, change in miles. The change in miles would be from hour 1 to hour 2. 120 miles minus 60 miles would give me 60 miles. That's the change between hours 1 and 2. Same thing over here, second hour minus the first hour will give me 1 hour. So I'm going 60 miles per hour. Now, I understand that kind of looks a little bit confusing, but this is the way they're going to set you up for when you don't know right off the bat how many you travel in 1 hour. Because in this case, we could literally just go to 1 and go up, and that's it. But if they give us a snapshot of somewhere different, that's where we want to have the subtraction go in so we understand and we can simplify to find out what the unit rate is. Explain what the points 0, 0, and 160 represent. The point 0, 0 represents traveling 0 miles in 0 hours. The point 160 represents traveling 60 miles in 1 hour. Notice that this is a constant rate of change. Again, it goes in a straight line, so we are having a consistent rate of change. This person is going 60 miles an hour consistently. All right, we're going to do these problems. So use the graph to find the constant rate of change in miles per hour while driving in the city. So again, we can look literally at 1 hour and know that we're going between 20 and 30, or 20 and 40, I should say. So it looks like we're going 30 miles an hour. 2, we go up to 60. So we are going 30 miles an hour. And it even says here that's 130. I didn't read that. So we are going 30 miles an hour. That's one way we can do it. Or we could look at points 2 and 3 and see that we went 2 and 60 and 3 and 90. 2 and 60, 3 and 90. So again, you're going to want the bigger numbers in front because we're going to subtract these. 90 minus 60 would be 30. 3 minus 2 would be 1, which gives us the fact that we're traveling 30 miles per 1 hour. So every hour we're traveling 30 miles. So that would be our answer there. On the lines below, explain what the points 0, 0, and 130 represent. So 0, 0 again represents no distance traveled and no time passing. We didn't leave, we didn't move, so we traveled 0 miles an hour because we also didn't go an hour. 130 means we went traveling for an hour and we traveled 30 miles. That's what the point 130 represents. All right, and we're going to look at our notes. Again, constant rate of change. Rate of change is a rate that shows how one quantity changes in relation to another. Constant rate of change is it has the same rate of change and will be a linear relationship. Again, when you graph a constant rate of change, it will be a straight diagonal line. Linear, a straight line on a graph. Slope is m equals y minus x, so we're going to get into that rise over run. So let's go ahead and get into that part of our lesson because we did not talk about slope yet. Oh, well, we're not talking about slope yet. So we'll hint at it. We'll hint at it. The fact that we're doing this and seeing how much it increases is called slope, and we'll just kind of entertain and introduce the idea of slope right now because that's not something we need to worry about. But just know when you're graphing things, if the x-coordinate keeps going up by the same number and the y-coordinate keeps going up by the same number, it is a constant rate of change. And then here with this example, we are looking at time in hours and distance. This person went 1 hour and looks like they traveled 4 miles. This one went 2 hours, looks like they traveled 8 miles. 3 hours, looks like they traveled 12 miles. This is a constant rate of change. It's going 4 miles up each hour. In order to do this, you would put your 2 points. So this is a different way of writing what we did. You would put y2 and y1, which again would be, we're picking on y2, so 2, and then 8, and then, 8 and 4, so y2 is 8, because we went up here, and y1 would be 4, because we went 1 up to 4. We went to 2, and we went to 1 for these ones. We would subtract them just like I did in the example, and this would give us 4 over 1, which again, you could just check by going 1 and then up. So this is saying we are going 4 miles per hour. And that is the entire lesson. If you guys have any questions, comments, or concerns, again, you guys can comment below. Otherwise, this is Mr. P signing off.